This is Mrs. O'Neill for Chapter 11, Section 1, Part 5, your practice problems for balancing equations. So some reminders first. Remember, you cannot change the subscripts of a formula because if you change those subscripts, you're changing the actual substance. For instance, going from CO to CO2, right? There's carbon monoxide versus carbon dioxide. You must use coefficients in order to balance the reaction. That's the only thing you can do or change to balance the reaction. You might want to look over or read over again the steps to balancing reactions in your student notes packet. And a reminder of that law of conservation. So if we start off with 5 atoms of gold, you must end up with 5 gold atoms. But that doesn't mean you need 5 of every kind of atom in your equation. So just some things to keep in mind. Also, for numbers 1 through 3, I actually put lines where those coefficients go, but in numbers 4 through 25, I just gave you spaces to put those coefficients. So again, numbers 1 through 3, I wanted to again remind you where you can put numbers to balance the equation, but really guys, you're never going to really see that. You're never going to see those lines. You're only going to see either the reaction or words to represent formulas that you have to write, like we did with that very first one when we did nitrogen plus hydrogen gives you ammonia. You might see it that way as well. All right, so what to do? Pause the video. Now, making that list of elements, it is up to you. There's plenty of room in the margins to do that on your notes packet, or you can use another piece of paper. And I want to remind you, if you feel comfortable balancing, you don't need to make that list at all. I will, however, tell you that in the past, some students are very comfortable with balancing most of the reactions. They can kind of spot check and go back and forth. However, sometimes when there's a reaction that has 4, 5, or 6 different elements to balance, it gets a little bit more challenging or a little bit more confusing, especially when you have oxygen in multiple substances, let's say, and we did one of those as an example. Then that student might feel more comfortable if they actually make the list because it just makes things a little bit easier. All right, so pause the video, do as many as you can, do it your way. I know some of you try to do all at one shot and then just check the answers. Or again, you can do, 1 or 2 at a time and then go through the video and check your answers. All right, so hopefully at this point, you've actually paused the video, you've tried at least 1, 2, or 3, if not all of them, and now we're going to go through the video. Now, the answers, however, I believe the first 5, I actually show you step by step. So I'm probably going to click through showing you those arrows and how I changed the coefficients and things like that. And I might say a couple things here and there, but then after number 5, I believe 6 and on, I just show you the balanced equation. And at that point, guys, if you do have something incorrect, make your adjustments, right? Correct your answers, but then you have a question mark or highlight it or something that says, hey, I need to see Mrs. O'Neill to get a better explanation on this one, or another student in class. All right, so here's number 1. Again, I'm going to try to click through. Here's the list. Here's the beginning values or the beginning numbers. And remember, chlorine here is in 2 different spots. So we have 2 plus the 4 here to give us the 6 total. All right, then clicking through, I got to put that 2 there first, which would change the calciums, and it's also going to change the chlorines. But remember, chlorine is in 2 different spots, so we got to add those up, the 4 plus the 4. So remember, we're multiplying here, but we add within, or I should say between compounds or substances. So multiply within the substance and add between substances. All right, and it doesn't look like we're balanced yet, so we're going to put a 4 there, multiply that out, and now we're balanced. So as a reminder, each individual element is the same amount on both sides, not that every single element has the same value. All right, here's number 2. Again, your list. And I like to usually put that roughly right under the arrow. And there again, that silicon is in 2 different substances as products. And the rest is pretty simple there. It is not balanced, so we put a 2 there to make 2 silicons as a reactant to equal the 2 silicons as a product. And then that's it. We're balanced. Some are this simple. And that's where, again, you might not have needed your list to do this one. All right, number 3. Now this one you might needed the list because there's multiple, oh my goodness, 1, 2, 3, 4, 5 different elements. And again, I'm still keeping that oxygen last. And now this one also has parentheses. So go through here. There's none on both sides here. Oh, I think I did that wrong. I wanted that arrow there. But yes, 2 times 3 to give you the 6 oxygens as a product. All right, going through, again, mercury is good. Chlorine, not so much. We're going to put, sorry, I don't know why that arrow came up again. So we have a 2 in front of the silver chloride. So we're going to change the 2 for the silver and then the 2 for the chlorine. So see how I did that? I go in order. So even though I was focused on the chlorine, because I put the 2 in front of the whole compound, I did it in order. I changed my silver number and then I changed my chlorine number. All right, so back to the top here. Mercury is good. Chlorine is good. Silver, not so much, so we're going to put a 2 there. But remember, the 2 is going to affect all 3 elements. So I'm going to change my silver, I'm going to change my nitrogen, and I'm going to change my oxygen. So now, guys, back to the top, I have the same amount of mercury's on both sides, the same amount of chlorines on both sides, the same amount of silvers on both sides, the same amount of nitrogens on both sides, and of course the same amount of oxygens. And again, they don't all equal each other, but each individual element equals itself as a reactant and product. All right, number 4, again, there's that list right away for you. And there we're going to change. I apologize. I should have crossed these off. I might have forgot, or I do it now. Sorry. And then again, I'm going to cross. Oops, sorry. I don't know what happened there. I'm going to cross off to put the 2 there. And if I notice, now everything is nicely balanced. And now on to the next one. All right. Oops, sorry. So we have number 5 there. Again, there's your list. It is not balanced. So we have to put a 2 in front of the silver to balance that out. And now we're going to put a 2 in front of the silver oxide to balance that. Now, notice, however, I went from a 2 to a 4 for my silver. So I balanced it the first time, then I went to balance my oxygens, but now this is one of those goofy ones where I got to change that subscript to make 4 back out on silver. So I'm going to actually go backwards real quick. So again, this is our starting point. I'm going to start by changing the amount of silver as my product. I'm going to change my reactants for oxygen, but my silver now changes again. And then I have to change my coefficient there to make sure that everything is totally balanced. So that's one of those weird ones where you have to change the coefficient at some point, and that happens. All right, so pause the video and look over. And number 7, isn't that awesome? I love it when they're already balanced. And if they're already balanced, you don't have to do anything. So I kind of suggest, kind of looking through and checking the amounts before you even start, because it is such a pain sometimes to, you make that whole list and then it's all balanced anyways. So there's not many of those out there. Obviously, I want to know that you know how to balance. So I'm going to most likely give you ones that you have to put some kind of coefficient. But again, sometimes they're going to be balanced. Sometimes you only need 1, 2 coefficients, and sometimes you need a coefficient in front of every single substance. So it just depends. Here's your 11 through 15, and again, number 12, you might have been able to catch that right away because there's no subscripts at all, so everything is 1, so that was pretty easy. Number 11 was pretty easy, and again, number 15 here, you needed a coefficient in front of each, and I believe that's one of those lowest common multiples, and you might have had to change your coefficients as well. 16 through 20 here. And if we look at, like, let's say 19, it looks really, really complicated. And look at that. You need 1 coefficient and it's balanced. So sometimes the more complicated it looks, sometimes it's really not that complicated at all. And hopefully you saw that this was chlorine. So this was carbon tetrachloride. So this is carbon and chlorine together. And the last set of 5. And yes, sometimes you need big numbers in order to balance the equation. So hopefully this is starting to make sense. Hopefully this was enough practice and examples, but you can always go back and rewatch or redo some of these to make sure you're understanding. All right, guys, we'll see you in class with questions and concerns.